Hey class, this video is on Pythagorean theorem, specifically using it multiple times. In every single example that we have, we're going to be using it twice. And these are problems that are just a little bit more difficult. I think you guys have a good understanding of using the Pythagorean theorem, whether that be finding a missing side or determining a length to a line on a coordinate grid. So these are problems that you may have seen on your Alex test. So I'm just realizing that you guys need, I think, some support for that. So that's what really this is serving. So I'll go and read example 1. It says, in the rectangular prism, this thing here, RU is 12 units, UT, I'm just labeling it here, is 40 units, ST is 41, and we want to find this diagonal right here. I highlighted this in yellow, and I think it may be off your notes. It's just RS. And then what we're going to do is we're going to try to find this length here. Now, the thing is, in order to find a side to a missing, or a missing side to a right triangle, we need at least 2 sides. Now, you can see that we have a right triangle right here. The thing is, we only have 1 here. If I need to find that, I need to find this one over here. So what we're going to do is we're going to use the information that is off to the right, where we have 40 and 41, and we're going to find that missing side, which is a leg to the right triangle. So if we're just going to put a squared plus b squared equal to c squared, this blue line that I have over here, that is a leg, so that's either going to be a or b. So instead of putting a, I'm just going to put that line segment, which is SU, and I'll put that squared. The other leg is 40. Those are the ones that are adjacent to the right angle. And c squared is 41 squared. And then what we're going to do is we're going to square 40 and 41. Just to give you a tip, if you ever multiply or square something that ends in 0, square the 4, so I get 16. And the exponent tells me how many zeros we have. So since it's squared, we have 2 zeros, so that's why it's 1600. And you can use a calculator, but 41 squared is 1681. Okay. We're going to subtract 1600 to both sides. So we're going to get SU squared equal to, and if you subtract, that's not too bad, it's just 81. So we're close to finding this length right here, because all I got to do is just square root both sides, and square root of 81 is 9 units. Okay, but the thing is, you could probably see that in your on your paper. We already said that this is 9 units here. You could label 9 right there. This is 12. Now we have 2 sides. That's going to give us this third side. So we're going to use the Pythagorean theorem again, now with this newfound information that SU is 9. So we want to find this red line here. So we have a leg of 12 and 9. So let's go and put in 12 and 9 in for B and A. And we're going to find C, which is RS. And that was the initial problem that was presented. So let's square these numbers. You guys can use the list of squares that's in front of the classroom. If we add these 2 numbers, we're going to get 225 equal to RU squared. Alright, and if you look at those lists, you notice that RU, or square root of 225, is 15 units. So you can leave it as RU equal to 15, or 15 UN. Alright, and that's it for the first problem. You're going to have an assignment that's very much like these problems. Yeah, just look at these problems to reference. Alright, next one. You may have seen this on the Alex test. It says, use information given in the figure to find the length BD. So I highlighted that here. We want to find this length that's upright. And the routes in there is whole number, and lengths on the figure are not drawn accurately. So maybe this isn't necessarily 7, this isn't necessarily 30, but just use those numbers for the purposes of this problem. So if we want to find this, right, ignore this line right here. If we want to find this, so we have the hypotenuse, but we don't have AD. But we can find that. We can find that using just highlighting this just smaller triangle. Ignoring everything else. So that has a hypotenuse of 25 and a length of 7 for the height. Alright. Now, I'm actually not going to work it out right here. I'm actually going to work this out on the back, because there's stuff that's already highlighted here. So we're going to work this out between these two. So first of all, we want to find AD in order for us to find BD. And you can already see AD is going to be 24, but let's figure out how do we get to that 24. So looking at this, 25 will be our C, our hypotenuse. We'll have 7 for A, so 7 squared, plus AD squared, so this line segment. All right, so let's go on and square some numbers. 225, you can multiply 25 by 25, but I'm going to give that to you right now. That is 625. We're going to subtract 49 to both sides to get AD squared. And guys, it's important to make sure that you are organized when you're solving these problems. If you subtract that, that's going to be 576. Finally, square root both sides. I know that these are big numbers, but you guys may use calculators on this and just try to experiment multiplying with numbers. It turns out that 24 times 24 is 576. So this is 24. And just working this out, guys, use common sense here. Right? We know the hypotenuse has to be the longest side, meaning this cannot be possibly bigger than that. It's got to be in between, right? Maybe 25, maybe 7, but definitely less than 25. So let's go ahead and now use our new information. So we're looking at this big triangle here. Hypotenuse, leg, and leg. All right, we don't know what BD is, so I'm going to put BD in for lowercase a. Our other leg is 24, so 24 squared. And then equal to C squared, that's our hypotenuse, which is 30. Alright, well the nice thing about this is we don't have to do like new information. We already know that 24 squared from here is 576. And then remember, if you end in a 0, just square 3, which is 9. And then this tells me add 2 zeros to the end of it, so that's 900. Let me just zoom in, just so you can see that. Okay, so we're going to subtract 576 to both sides. I'm not going to write it, I'm just going to give you what that is. So we're going to have BD squared equal to, when you subtract it, it is 324. And you can find out what this is. This is, BD is going to be 18 units. Alright, so this line segment, 18. Alright, so we just had to do it twice, right? So when you see problems like this, think about what information is helpful, what do you have, and how can you use that to try to complete the problem. Alright, the last one, a problem that, although we're going to have big numbers, I want you guys to understand the thought process behind it. So although we have big numbers, don't let that be something that like gets in the way, right? You have calculators, you guys can compute this. So I filled in some information here. So first of all, I want you to look at this box. It's a rectangular prism just like the first one, but we're finding a different line segment. So we have PT is 65. So PT is the diagonal length from P to T, this like front side of this box. PQ is like the bottom, this is the base. PR is a diagonal line going from, it's like, think about like the bottom of a box. So if I have a box, here's just a bunch of batteries. It's like a diagonal length going from here, but it's just like at the bottom of this box. Okay. And we want to find what PS is. So I highlighted that in, I don't know what color that is, but that's yellow probably. We want to find the line segment from P to S. So if you look at the box here, you're really thinking about like opposite, what we call vertices, is like, let's say right here and right here. If I were to have a string going through the middle of this box, what would that length be? So we have to find some parts of this. So we're going to start out by, we need, if you look at, there's an inside triangle formed by this yellow line, this green line, and this upright line SR. So it's inside. So we have the bottom part of that inside triangle, that's 80. We want to find this, so meaning I want to find this upright side right here, SR. Now we don't have any information that's close to it, but you may notice that we have 52 and 65 right here, and that will give us this upright length, where that, if you take that and move it, it's the same length as this. So whatever this is, SR is going to be the same thing. So let's go ahead and try to figure out what that is. So let's go ahead and put, so we have the hypotenuse, which is 65, I'll put 52 squared plus, we want to find TQ. So put TQ squared equal to 65 squared. I'm just going to give you what those answers are. So 52 squared is a big number. 2,704 plus TQ squared. And then 65 squared is 4,225. If you subtract, because you need to isolate your variable. So we have TQ squared equal to, if you subtract this, it's going to be 1,521. Put it into your calculator. Right, if you put it into your calculator, just press the square root button. You're going to find the square root of that number is 39. So we know that TQ is 39 units, which means SR, right? Look right over here. This last part of the diagram is also 39 units. So we're looking at this inside part. We have the base of 80. We have this upright length of 39. Let's find this red like dash marks through the rectangular prism. So we don't know what this is. This is the hypotenuse. So it's going to put 80 for A, 39 for B, and the hypotenuse we're just going to put as PS. So, right, this 8 squared is 64 plus 2 zeros. Nice. We're 39 squared we already did on above. That is 1,521. And if you add this is going to be 7,921 equal to PS squared. If you square root both sides, you're going to get PS, and I'll switch it, is equal to 89 units. Boy, God, we just completed this. Guys, believe in yourself. Yes, these are difficult, but you guys need to be challenged. Going to try these problems on your assignment. Let me know if you guys got questions. Peace.